Hello students, today we learn about the important terms which is used in hydrodynamic journal bearings. For that purpose, we first see this figure number 1 for hydrodynamic journal bearing. This outer circle is nothing but bearing. This inner circle is the representation of journal, and the gap between bearing and journal, here the lubrication is present or lubricant is present. O is the center point for this journal. O dash is the center point for this bearing, and if we connect this center to center distance, or from center, if we draw the line, this line is called as line of centers, which is passes through this O and O dash. Here D, capital D letter, is used for diameter of this bearing, and this R is the radius of bearing, capital letter, that is R, and this small d, which is used for diameter of journal, and this small r, which represents the radius of the journal. Now if we consider this L symbol is for length of the bearing. Now the following terms used in hydrodynamic journal bearings are important from the subject point of view. First point, that is called as diametral clearance. We use diametral clearance by using this C symbol. It is the difference between the diameters of the bearing and the journal. If we see this figure, in this figure, this difference between D and this D is called as diametral clearance. So C is equal to D minus D. A commonly used clearance in industrial machine is 0.025 mm per centimeter of journal diameter. As the size of journal increases, then according to that increase in centimeters, we increase this value 0.025 millimeters. Second term is the radial clearance. It is the distance between the radii of the bearing and the journal. Mathematically, radial clearance is represented with C1 symbol, which is equal to radius of bearing minus radius of journal. So in this diagram, this R minus R, this distance is nothing but C1. In terms of diameters, so which is equal to D minus D divided by 2, but we know that D minus D is the diametral clearance C. So in place of D minus D we substitute this C. Therefore C1 or radial clearance is equal to diametral clearance C divided by 2. This is the radial clearance. If we see the next term, that is diametral clearance ratio. It is the ratio of the diametral clearance to the diameter of the journal. That is, if we see the mathematically, the diametral clearance ratio is equal to C divided by D. But we know that C is D minus D. Therefore, diametral clearance ratio is equal to D minus D divided by D. Next important term is called as eccentricity. So if we see in this diagram number 1 again, then if we observe here, this distance between O and O dash, this is called as eccentricity, and which is represented with symbol E. So if we see the definition, it is the radial distance between the center O of the bearing and the displaced center O dash of the bearing under load. It is denoted by E. Next term is minimum oil film thickness. It is the minimum distance between the bearing and the journal under complete lubrication condition. It is denoted by HO and occurs at the line of centers as shown in figure number 1. So in this diagram, if we observe the line of center, then if we observe the gap between the journal and bearing at on this line, this distance is called as HO. So this is minimum oil film thickness. Its value may be assumed as C divided by 4. Next is 6th point, that is attitude or eccentricity ratio. It is the ratio of the eccentricity to the radial clearance. Mathematically, attitude or eccentricity ratio, that is eccentricity, is equal to that E, that is eccentricity, divided by C1, which is equal to uh, we know that so E is C1 minus HO divided by C1, which is equal to 1 minus HO divided by C1, which is equal to 1 minus 2 HO upon C, because we know that C1 is equal to C upon 2. So in place of C1, if we substitute C upon 2, then our equation is eccentricity ratio is equal to 1 minus 2 HO upon C. If we see the next term, that is short and long bearing, it is the ratio of the length to the diameter of the journal, that is L divided by D. If L divided by D is less than 1, then the bearing is said to be short bearing, and if L upon D is greater than 1, then the bearing is known as long bearing. So in this way we find out which bearing is short bearing and which bearing is long bearing. Along with this, one more important point is that when the length of the journal, that is L, is equal to the diameter of the journal D, then the bearing is called square bearing. So in this way, today we learn about the terms used in hydrodynamic journal bearing, that is diametral clearance, radial clearance, then we see the diametral clearance ratio, eccentricity, minimum oil film thickness, attitude or eccentricity ratio, and the short and long bearing. So here we finish our lecture. Thank you.